So, evaluate limits graphically. Today we're going to focus on graphically. So, limits, this idea of a limit, that's what chapter 1 is about. What is a limit? Okay. There are 3 ways. We'll talk about what a limit is in a second here, but there are 3 ways to evaluate it graphically, which we're going to do today, using a table and analytically. Okay. Graphically, we won't spend too much time on because it's probably the easiest way. So they don't give that to you a lot. Okay. Um, Using a table takes a while because you got to make the table. So the most common way is the third way, which we'll spend the most time on. We will spend the most time on number 3, but we just won't do that today. Okay. So now let's go over what in the world a limit is. Okay, this is what a limit is. So if I have an equation, y equals x minus 4, and I plug in 5, okay, what's the answer going to be? 1, right? 1. You've been doing that since math 1, right? That's just algebra, right? But with a limit, we're not actually plugging in the number. We're approaching the number. So there's a difference between getting there and approaching there. So what you guys have been doing is getting to your destination. What a limit does is approach. I'm not worried about getting there. I'm worried about where am I approaching? Where am I approaching? Am I approaching here or am I approaching somewhere different? That's where a limit is that's where a limit is different. Yeah. Yes, you do. Yep, but you guys can't sit next to each other. I was waiting for you guys to get ready. Whenever you guys are ready, I would give it to you. Okay. Um, so, for example, the limit as x approaches 5 for the function. There will always be a function here. The function's the second part. Sometimes it says f of x, sometimes it actually gives you a function. So for example, the limit as x approaches 5 for the function x minus 4. Now that doesn't mean what happens when I plug in 5. What that means is what happens as x is approaching 5. So what do I mean by approaching? Well, think of a number line. Negative, let me draw it over here so we can see it on the recording. So a number line goes from negative infinity to positive infinity. Okay. So what this question is saying is what happens as we approach 5? We get closer and closer to 5. Okay. So 5 is right there. Then you got 4, you got 6, you got 7, you got 8, you got 3, you got 2. You can keep writing all these numbers, right? So I'm going to highlight this one because this is the guy we're looking for, 5, right? So what this limit says is, as I get closer and closer this way, so coming this way, what number am I approaching? Not 5, 1. The answer is always going to be the y value. X is approaching 5. I'm approaching 5 here. So as I approach 5 from either side, I'm getting to 5. I know I'm getting to 5. But what is the answer going to be? That's what I'm saying. What is the answer going to be? I know I'm getting closer and closer to 5 in both sides. What is the answer getting closer to and closer to and closer to as I get closer to 5? So when I plug in 1, when I plug in 2, when I plug in 3, when I plug in 4, when I plug in 4.5, when I plug in 4.6, when I plug in 4.7, 4.8, 4.9, 4.99, 4.999999999, what answer, what y value am I getting closer to? What y value am I approaching? Okay, that is what a limit is. What y value am I approaching? Okay, from either side. Let me start over here. Let's start on the higher side. 8. When I plug in 8 for x, when I plug in 7 for x, when I plug in 6 for x, when I plug in 5.5, 5.4, 5.3, 5.1, 5.01, 5.001, 5.00, I'm getting closer and closer to 5, right? Every time I plug those in here, every time I plug those in here, what y value am I coming closer to? 4. Or sorry, 1. Sorry, 1. Because as I plug in numbers closer and closer to 5, my answer here is getting closer and closer and closer and closer and closer to 1, right? I know when I plug in 5, I get 1. 5 minus 4 is 1. No secret there. But sometimes that won't be the case. Sometimes when you plug in this number here, because a lot of you are saying, why don't you just plug in 5 in here and get 1 as an answer? If you can do that, do that. But I'm telling you right now, in this class, that's rarely the case. Okay? Because what happens when you do that, if you find that, if you can do that, if you could plug in this number in here and get an answer, happy day. You guys should be happy, move on to the next problem. What will happen in this class is that when you plug that in, it'll give you something undefined. It'll give you something, something that isn't a number. That's why we're going to run into things like that. Today, we won't. Today, we won't because I'm just introducing what we do. But because every time I introduce this lesson, you're like, well, why don't you just plug in 5 and be done with it? If you can do that, do that. Move on to the next thing. But it's not always going to be that easy. Okay? So what the idea is as I'm approaching this number here, as I'm approaching this number here on the number line or on the graph, which y value am I approaching? That's the question. What y value am I approaching? Okay? So that's what this says. As x approaches a number, the limit is equal to the y value you're approaching. The y value you are approaching. Okay? That's the limit. The limit is always going to be equal to the y value, not the x value, the y value. The x value is already told. We're approaching 5. They'll always tell you where you're approaching, but you have to determine what y value you're approaching. Okay? So for all of these problems that we do today, think of the y's. Don't think in terms of x's, think in terms of y's. Okay? All right, so that's pretty much says exactly what this says here. If the y value of a function becomes close to a single value as x gets closer and closer to a point from both left and right, then the limit, that's the limit. Okay? So that just says exactly what I just said, but hopefully a little clearer. Okay? So let's do an example. Let's do an example here. Number 1. So we're working with graphs today, so we're going to have to graph. If they don't give us a graph, we're going to have to graph. Luckily, the graphs today aren't that bad. Okay, so we have to use the graph to find the limit as x approaches 2. Okay, so we're going to graph g of x. G of x is a piecewise function. Piecewise means it has 2 pieces, or it has more than one piece. When x is equal to 2, y is always going to be 0. When x is not 2, it's always going to be 1. So we have to draw that graph. How do I draw that graph? How do I draw a graph that y is always 1 when x is not 2? But when x is 2, it's equal to 0. How do I draw that graph? So in other words, this is what you're doing. We're drawing 2 graphs. In other words, this is just y equals. So we're drawing y equals 1, and we're drawing y equals 0. Now, we're not drawing them everywhere. We're drawing them wherever they exist. So let's start with y equals 1. Let's start with the first one. Where does that, well, what does that look like? It's a straight line. What does y equals 1 look like? What is it going to look like? Exactly, horizontal. And it's going to cross where y equals 1. Okay, so y equals 1 right here. So it's going to look like that. Okay. There's a problem, though. What's the problem with drawing that line? What's the problem with drawing that line? What's the domain for that line that I just drew? It goes everywhere, right? Negative infinity to positive infinity. There's no stops. But that's not what the function says. The function says it's okay when x is not equal to 2. But when x is equal to 2, it's somewhere else. Where is it? What is y when x is equal to 2? 0. So when x equals 2, that's right there. My answer won't be 1. So what I'm going to do is I'm going to draw a little like hole. Okay. And when x equals 2, the answer is 0. So that means it's going to be a dot right there. The hole is there because it's missing. The answer is not there. It's right below it. Okay. That's what that means. So everywhere on the graph is y equals 1. Y equals 1 has free reign everywhere, except when x equals 2. When x equals 2, it's got to be somewhere else. And where is it at? It's at y equals 0. Okay, so that's what the graph's going to look like. Okay. Now that we got that, now we can answer this. Now we got to answer the limit as x approaches 2 for g of x. That's what we got to answer. The graph wasn't the question. The graph was just something we needed to do. Okay. So this is what I do for graphs. This is what I do for graphs. I use my finger or my pencil. I start on the left. So I'm going to start on the left. And I'm going to move right. Where am I approaching? Where should x be approaching? Where should x be approaching? 2. So as I get closer and closer to 2, what question am I asking? What's the y value? Good. What is the y value? As my finger gets closer and closer to x equals 2, what's the y value? Okay. Okay, so let's do this. So as my finger gets closer, let me do it since I'm recording it. Let me do it on here. So I'm starting over here. So as I get closer and closer to 2, what's the y value? 1. Okay, so from the left side, the limit is 1. What about from the right side? Is it the same thing? Am I also approaching y equals 1? Yes. So what's the answer? 1. Let me make it even more confusing if it wasn't already confusing. What if this was an answer? What if they wanted this? What if that was a question on a test? Not the limit, g of 2. 0. There you go. Because that's where the dot is. When it says g of 2, g of 3, g of whatever, that's where is the dot? Where is the dot? When it's saying limit, we don't care about dots. I just care about where the graph is. Okay? All right. Okay. So for a limit to exist, so you see, or actually before we do that, you see these little pluses and minuses in the box here, the little pluses and minuses up here? Sometimes you're going to see that. Those are called one-sided limits. That means you're coming from the positive side. So you know how we did, you know how I just did like this? I did one of these guys. I was like coming from this side or coming from this side. That's what I mean. Okay. So if it's got a little plus here, you're coming from the positive side. What side is the positive side? Yeah, you're coming from the right side. These are all the positives are, right? The positives are here, so you're coming this way. If it's got a little minus, that means you're coming from the left side. So sometimes students turn that around because they're like, I had students say, well, I'm going left. Isn't that negative? Yeah, you're going that way, but you're coming from the positive side, right? It's where you originate from. Okay. So over here, if I go this way on the graph, that is the negative side. Why is that not showing? There you go. Delayed a little bit. If you come from this side, that is the positive side. Okay, so in your notes, make sure it does say that actually, approaches from the right, approaches from the left. It does say that. So right goes, so you're coming from the right side. You're not going right, you're coming from the right side. Approaches from the left means you're coming from the left side. Okay, plus means go where the pluses are, go where the positives are. Minus means go where the minuses are. Okay, that's what that means. So sometimes it can be a little confusing as to which way. They didn't take roll. I think everyone's here. Okay. All right. That's what that is. That's pretty easy, but again, that's all that means. That's all those pluses and minuses mean. Okay. The next one is a limit exists. So it's possible for a limit to not exist. Okay. It's possible for a limit to not exist. When does it exist and when does it not exist? Well, example number one, it existed, right? How do I know it existed? Because I got an answer. If you get an answer, it exists. When does it not exist? This is when it doesn't exist. If coming from the coming from the right is not the same y as coming from the left. If you approach two different places coming from different ways, it doesn't exist. Okay? If you do approach the same, it does exist. Okay? So for example, let's go back to this one. This one existed because coming from this side over here, I was approaching y equals 1. Coming from this side over here, I was also approaching y equals 1. Let's say one side was approaching y equals 1, and one side was approaching y equals, 4? Limit would not exist. So you would just write, instead of 1, we would have put d n e. Limit does not exist. That's how a limit doesn't exist. Sometimes their limit won't exist. Okay, sometimes that's the case. If you're coming in this way and you're coming in the same spot, you're good. If you're coming in and it's a different spot, they end up at different spots, limit doesn't exist. Okay. All right, so let's do this one now. So now we're going to graph number 2. Number 2 is 2 lines. There are 2 lines. It's a piecewise function again. So you got one piece up here and you got one piece down there. Okay, they're both linear. So to graph lines, you usually start with the y-axis, the y-intercept, sorry. So I'm going to graph the first one. I'll highlight that in this color. The y-intercept is 5. So I'm going to make a dot at positive 5. 1, 2, 3, 1, 2, 3, 4, 5. The slope is negative 2. So I'm going to go down 2 over 1, down 2 over 1. And then I'm going to connect the dots. The other one is x minus 3. So the y-intercept is at negative 3. And the slope is 1. So up 1 over 1, up 1 over 1. Okay, draw those two lines. That's wrong. If I were to do that on a test, that would be wrong. What's wrong? What did I not take into account? The lines are perfect. There's nothing wrong with the lines, but there's something wrong with the graph. What's wrong with the graph? Something that was wrong with this graph here that we had to fix. Same situation down here. Not going to be a hole on this one, but there are restrictions. There are something called domain restrictions. That's these guys here. The orange guy, yellow orange guy can only exist when x is greater than 2. So it can only exist. So it can't exist less than 2. So the orange line, I have to erase everywhere x is less than 2. So x is 2 here. So everywhere before it, I have to erase. And it can't even equal 2. It can't even equal 2. So I have to have a hole there. And then the blue line only can exist when x is equal to 2 or less. Equal to 2 or less. So over here, it can't exist either. It's called domain restrictions. Restricts where the graph is. Okay? That's what the graph looks like. When x is greater than 2, it's orange. When x is less than equal to or less than 2, it's blue. So okay, that's step A. Step letter B. Okay, find the limit as x approaches 2 only from the left side. Only from the left side because of that negative, right? That negative here means only from the left side. Only from the left side. Okay, so 2 is here. X equals 2 is right there. So which way am I going to start on? Blue or yellow or yellow, orange, whatever color that is? Blue, only on blue because blue is coming from the left side. So I'm going to start over here and I'm coming here. So as I get close to x equals 2, what's y equal to? As I follow this blue line, what is y approaching? Negative 1. Negative 1. So that equals negative 1. Because I only came from the left side on that one. Okay. Letter C. Now I'm still approaching x equals 2, but I'm coming only from the right. Only from the right. So if I'm coming only from the right, I have to go to this yellow-orange thing. And as I approach x equals 2, which y value am I approaching? Positive 1. Positive 1. Okay. Yes. That's what we're going to talk about. Yep. The next question is, okay, what's the overall limit? There you go. Why is it does not exist? Because they don't lead to the same y value at that point. Coming from here, the y value is leading to -1. Coming over here, the y value is leading to 1. Those are different points. I'm leading to different points. I don't meet at the same point. So because of that, you are right. It's going to be DNE or does not exist. What time we got? Okay, we got plenty of time. All right, so now let me do this one. It's not on here, but I'm going to add one on here because I want to see if you guys got this or not. What is the limit? So this is letter, we'll call this letter E. What is the limit as x approaches, 1 for f of x? I want you to do that one. Give you a minute to do that one. What is the limit as x approaches positive 1 for f of x? We're going to go over it. I'll give you about 30 more seconds to see what you come up with. We're going to go over it. We'll talk about it, but just try it on your own. See what you come up with. Okay. All right. So, first of all, for E, there are no pluses and minuses, right? There are no pluses and minuses, so we have to come from both ways. There's no plus or there's no minus there, right? It has to come from both ways. Okay. So let's go to where x equals 1. It's right here. So it's right there. F of 1 is -2. So on the blue, we have to come from one side. So I'm coming from this side here. As I approach x equals 1, what y value am I approaching? -2 from this side, right? Now let's go for the other side. Start here. Oh, but then I jump, right? I jump over back to this one if I want to go right. And which y value am I approaching? -2. Approaching the same one. So that guy will have a limit, -2. Okay, so just be careful with that. Where it jumps, it's called jump discontinuity. We'll talk about that later in the chapter, but this is called jump discontinuity because it jumps from one thing to another. It jumps from, if I'm coming from the positive side and I'm going this way, it goes here and then it jumps over here, right? Or the other way, if it goes here, then jump, right? Okay. All right. Okay, so one last thing. Big graph. Big graph, lots of things happening. Lots of questions here. Okay, so we're going to do this. We're going to do the first couple together, and then I'm going to turn you loose and see what you come up with, and we'll grade it. We'll go over it at the end. Okay. All right. So big graph, f of x. The whole graph is f of x. So 0. X equals 0. No pluses and minuses, right? There's no pluses and minuses at the 0. It's just 0. So we have to come from the left side and we have to come from the right side. Okay. So I'm going to come. Mine is blue. Yours isn't because it didn't color copy, but it's the same graph. So I'm coming from the negative side. As I get closer to x equals 0, what y value am I approaching? 6. Good. Now let me go to the other side. Start over here. Jump. As I approach x equals 0 from this side, which y value am I approaching? So the is 6. Okay. Letter B. Letter B is positive 6 only from the left side. Letter 6 is positive 6 only from the left side. Okay, so from the left side means start over here, positive 6. So we go, as I approach this guy right here, only from one side, right? So only from one side. If I only approach from one side, it always exists. The only time you might get DNE is if it's from both sides. Okay, so it's from the left side. So as I approach, which y value am I approaching? 4. 4. Okay, so I want you to do the rest. Don't worry about letter D. Letter D, skip that one for right now. Skip that one for right now. If you want to try it, go for it. But once you look into it, you'll understand why I want you to skip it. Okay, so I'll give you about 5 minutes. Finish the rest. Okay, so let's take a look at it. Letter C. Positive 2 only coming from the left. Positive 2 only coming from the left. So positive 2, x equals positive 2 is right here. So if we only come from the left, I have to come from here. And as I'm approaching x equals 2, which y value am I approaching? 0. Skip letter D for right now. We'll go to letter E. We'll come back to letter D, but we'll go to letter E. Letter E is 1 from both sides. Positive 1 from both sides, right here. So as I approach from this side, y is equal to 3. As I approach from this side, it's the same place, right? Now, is that the answer to x equals 1? It won't be the answer, but it is the limit. F of 1. Here's the next question. F of 1. What's the y value answer? What's the y value answer when x equals 1? 1. Yeah, it's not 2 or 3, sorry. It's actually 1 because the dot is down there. The dot is actually down there, okay? So when we're looking for f of 1, f of 2, you look for the dot. That's the answer. That's F and G is when we plug in numbers. Limits, we don't plug in numbers because that's not the idea. It's approaching. Okay, f of 2. F of 2, what's the y value when x equals 2? There you go, 2. And then letter H, what is the limit as x approaches 2? Not 0. I heard somewhere over here. Does not exist. Yeah. Does not exist. Because if I come from this side over here, I approach 0. If I come from this side over here, I approach 2. Different numbers, different does not exist. Okay. All right, let me go back. Let me double back real quick to letter D. What's wrong with that question? Take a look at it. If you haven't already, take a look at it. Why did I have you skip it? Take a look at it. If you haven't already, if you didn't look at it now. I'll give you 30 seconds to a minute. Look at it. Tell me what's wrong with it. Why did I have you skip it? Mm-hmm.
It's not approaching its array there.
It's not approaching what?
It's not approaching its array there.
So yeah, -6. Yeah. So it's actually a value of -6, right? It's not approaching from one side or the other. It's approaching from both sides. What's the problem with approaching from both sides for -6? X equals -6. Mm-hmm. There's nothing on the left side. It ends at -6, right? So how can we tell where it approaches? Does it approach from there? Does it approach from there? The graph ends there, right? So it was a typo. It was a typo, so it was supposed to be negative up here. It was supposed to be a negative there. Otherwise, it doesn't make any sense. How do you find the trail of something there is no trail? Like, how do you follow someone where you don't know where they went? That's kind of the same idea, right? You can't, right? So that's what it's supposed to be. Or sorry, not that. Plus. It's supposed to be plus, sorry. From the positive side, because that's the only way we can come from, right? We can only come from the right side. We can't go from the left side. So we would go here, here, here. So as I approach, that would be 0. Yeah, because originally I saw that one and I'm like, that one's wrong. But I remember from last year that it was a typo because you can't approach something from two sides if there isn't two sides. Okay. All right. So I didn't print out the assignment because I wasn't sure if we'd have time to start it in class. But what I'll do is I'll upload it. I'm going to upload the assignment. It's just so the assignment's going to be a worksheet. Let's see if I can find it. I'll show you the worksheet right now since we have some time. Let's see here. Let's see. I believe this is it. Let me show you. This is the worksheet. It's just the worksheet. Like I said, I didn't make copies for you guys because I wasn't sure if we'd finish in time. So it's two graphs. There's one graph. There's the other graph. Kind of like you did, just more practice. Okay, I'm going to post that later today on Google Classroom. It won't be due. Any assignment I give you, I always give you 2 days, even if you don't need it. This, if you sit down and do it, it'll probably take you like 5-10 minutes. It won't take you that long, right? As long as the homework, the notes just took you that last example number 3. It won't take you very long. But I always give you 2 days to do it, just in case. So I'll post it today. It'll be due Friday by the end of class. Now, do you have to print this out? No, you don't have to print this out. You can do this on another sheet of paper. It's okay if you do this on another sheet of paper. I don't mind. So what you're going to do to turn it in, you don't turn in papers to me. You turn it in digitally. You go to Google Classroom and then you just scan and upload it. Okay, you can use your phone to do that. If you don't have a phone, the Chromebooks can do that too. I'll show you how to do that. So you can do that too. The Chromebooks can do it. That's the way you turn in work. Sometimes we'll do it on paper. Sometimes we'll do it on Delta Math. This one we'll do on paper first. Okay, so I'm going to post this. Like I said, it's 16 problems. You don't have to draw the graphs. You don't have to draw the graphs again. I don't, if you do it on paper, you don't have to redraw the graphs. Any work you do, that's what I want to see. But this is not really a lot of work. You just look at the picture and decide. There's no math to it, right? You're just analyzing the graph. Okay. All right. Let's see. Anything else? I think that's about it. Okay.